Write the fractions in the left column as mixed numbers, and write the mixed numbers in the right column as fractions greater than 1, or an improper fraction. So for these, we think about how many 9s fit into 68. 9 times 7 is 63. To get from 63 to 68, that's an extra 5. So 7 wholes and then 5 extra pieces. For these, we're going to multiply. 10 times 8 is 80, and then we add 7, 87, and we keep the same denominator, so 87/8. Complete the remaining 6 problems for your warm-up. How many pores of the measuring cup can fill a 1-liter cylinder? So these are quarter liters. So if we make a prediction like 3, we can try it. And we see that's not enough. To get 1 whole liter using fourths, we would need 4. And you can see, yes, that is correct. How many pores of the measuring cup can fill a 2-liter cylinder? We need to put in a value. So if I wanted 1/3 of a liter measuring cup, 3 of them would fill 1 liter, so I would need 6 of them to fill 2 liters. And then we can try it. If I had half of a liter, it would take 2 to fill the first liter and 2 to fill the second liter, so it would require 4 pores. Write a number sentence that represents the situation. Now there are actually 2 number sentences we can write. We could say 1/2 times 4 would give us 2 liters. Or we could also write the number sentence 2 liters split up. 2 liters split up into half-liter sections would give us 4 of those half-liter measuring cups to fill it. It says explain how the interactive models your number sentence. It takes 4 of the 1/2 measuring cups to fill a 2-liter container. How many pores of the measuring cup can fill the cylinder? Let's try 2. That is not quite enough. Consider the number of pores of 1/3 liter that can fill 2 liters. It would take 3 to fill 1, so 6 to fill 2. How does this number help you determine the number of pores of 2/3 liters that can fill 2 liters? So if 1/3 takes 6 pores, then 2/3 would need fewer pores. This is double, so we would need half as many. How many pores of the measuring cup can fill the cylinder? Well, it would take 5 1/5 to fill a cylinder. So I'm going to write that down. 5 1/5 to fill 1. So it would take 15 1/5 to fill 3 of them. But we have 3/5. So I can split 15 into 3. So it should take 5 3/5 to fill 3. And let's try it. How can you determine the number of pores by only using the numbers? We can think about 3/5 multiplied by some number, or by what number, would equal 3, because we're trying to get to 3 liters. Or we can think of it as 3 is split into groups that are 3/5 in size. How many pores of the measuring cup can fill the cylinder? So to fill 1 liter using regular fourths, it would require 4 of them. To fill 4 liters using 1/4, it would take 4 times as much, so 16 pores. But we have 4 liters using a 3/4 measuring cup. So we're going to split 16 into 3 instead of using 1/4. Is this going to be a whole amount of pores? Let's check. Okay, 4 is too few. Let's try 5. Five is still not enough. How about 6? Oh, 6 spills over. So can a whole number of pores fill the cylinder completely? No. How do you know? We tried 5 and that did not fill it. It's not enough. But when we tried 6, it overflowed. Use the interactive to help make a conjecture. It would take 16 fours from the 1/4 measurement, but 16 is not divisible by 3. We just saw that 3/4 does not fill 4 liters with a whole amount of pores. So in here, on slide 6, it says 6 pores of how many liters each will fill the cylinder completely. So we need to change this fraction, or the size of the pore, so that we can get exactly 6 pores. So we had that 6 pores was too much. So if 3/4 is too much, we need to reduce this fraction. Let's try reducing the numerator. Well, that isn't quite right. So let's do some math. If we had 6 pores, 6 times what number would equal 4? I could change these to fraction pieces. 4 could also be written as 16/4 if we wanted to make it fourths. We could write it as 12/3. Let's try that. 12/3. In order to get 6 times something that equals 12, that would be a 2. And 1 times something that equals 3. Well, 1 times 3 equals 3. So let's try 2/3. Try it. And we get, yes, that works. But we're looking at like guessing and checking here. And we want a strategy that would work all the time. So if I want 4 liters, I could think of it as 6 fours split over the 4 liters, and 6 divided by, well, that wouldn't work. We want the 4 liters to be split into 6 pores. 4 divided by 6 is just 4/6. Or we could reduce that and get 2/3. So we can take the amount of liters and divide by how many pores there are to figure out how large each pore needs to be. Using the tape diagram, evaluate 4 divided by 2/3. So here I have 1, 2, 3, 4 holes. And here I have 4 split into 1/3. How many groups of 1/3 are in 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 1/3 in 4. Now we need to think of it as how many 2/3. So we're going to reset that. I have 4 holes, but this time I'm adding 2/3. So each chunk is going to take up 2 sections. 2/3. And it takes 6 of them. How do you find 4 divided by 2/3? We need to figure out how many 2/3 will fit into 4. We can split the holes into 3 sections because it is broken in thirds. Then we will shade in or select 2 parts or 2/3, or to represent 2/3. Use the tape diagram to evaluate 5 divided by 3/4. So I have 5 holes, 1, 2, 3, 4, 5. And since we're looking at fourths, each of those holes is split into 4 parts. Now we're going to fill it in with 1/4 size pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now we're going to do groups of 3/4. So I'm changing this to say 3/4. And now each time I'm going to take up 3 of those 4 sections. So there's 1, 2, 3, 4, 5, 6, and a piece. So I had 6 holes, and then I have 2 parts left over out of the 3 that I needed to make a group. Two out of 3. Oops. 6 and 2 out of 3. How are the 2 questions related? We split both of them into parts, or into 4 set parts in each hole, because they are fourths. In the first, we shaded sections that were 1, and in the second problem, we shaded sections that took up 3. Mr. Evans buys 6 sandwiches for a class party. Each student eats exactly 3/5 of a sandwich. The students eat all of the sandwiches. How many students eat sandwiches? So 6 is split into 3/5, which means we have 1, 2, 3, 4, 5, 6 holes, and each hole has 5 parts because they're split into fifths. And we are shading in 3 at a time. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many students eat the sandwiches? 10 students. How does the tape diagram show the number of students who eat 3/5 of a sandwich? It shows that 10 sets of 3/5 fit into 6 holes. Right here you can see 10 times 3/5 fills 6 holes. Miss Song wants to make lemonade with 8 pounds of lemons. She needs 3/4 pounds of lemons to make 1 liter of lemonade. How many liters of lemonade can Miss Song make? So she has 8 pounds, so we're going to fill in a tape diagram that has 8. 1, 2, 3, 4, 5, 6, 7, 8. And we need to split each of those into 4 parts because we're using 3/4. Okay, and we're filling in sections that are 3/4. So we're filling in sections of 3. There's one section. Here's a second section. A third section. A fourth section. A fifth section. A sixth section. A seventh section. 8 sections. 9. 10. And I have 2 left out of 3 that I need to make a group. So 10 and 2 out of 3 that I need to make another group. So she can make 10 and 2/3 of a liter. Oops. And now use the tape diagram to confirm. Okay, so I have 8. It's split into 4s. We're going to shade in 3. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2 left, but we need 3 to make another group, so 2/3. And our last slide, slide 11. Miss Baker buys 6 pounds of blueberries, and she wants to put the blueberries in bags. Each bag holds 1 1/3 pounds of blueberries. How many bags can Miss Baker fill with the blueberries? Let's start by changing 1 1/3 to an improper fraction. 1 times 3 is 3, plus the 1 from the numerator turns it into 4/3. So we are splitting 6 into 4/3. Again, if we draw a tape diagram with 6, we need to split it into 3 pieces in each of those sections. And we're going to shade in 4 pieces at a time. We have 1, 2, 3, 4, and 2 pieces out of the 4 that we need to make a group. So 4 and 2/4, or we can reduce that to be 4 and 1/2. So they can make 4 1/2 bags of blueberries. Use the tape diagram to confirm. So I have 6 holes, 1, 2, 3, 4, 5, 6. It's split into 3 parts, and we're shading in 4 at a time. 1, 2, 3, 4. 5 is too much, so we have 4 holes and 2 out of the 4 to make the next group. Make sure your workbook is filled in with any notes from today's lesson and that your warm-ups are completed.